Today we are discussing about 1 to 4 demultiplexer. In 1 to 4 demultiplexers we have a number of inputs 1, number of outputs 4 means 2 raised to power 2 and number of selection lines equal to 2. So the number of inputs we will abbreviate it as I, outputs D0, D1, D2 and D3 and selection lines S0 and S1. So we also know that the selection lines determine which one of the four outputs means D0, D1, D2 to D3 is routed from input. Means that it decides that which output line will be selected to route the input as an output. So this is a first point that we must know. Second point is about its block diagram. Block diagram is one to 4 demux. This is one input line I, 4 outputs D0, D1, D2 and D3, obviously 2 selection lines S0 and S1, and we also have a active low enable. So this is the block diagram. One input, these are 2 selection lines, these 4 are the number of outputs. Now the third thing that we must know is the truth table. Truth table has first selection lines S1 and S0, and we know that we can have 4 combinations 0 0 0 1 1 0 and 1 1. These are outputs. Outputs are, we are taking D0, D1, D2 and D3, total of 4 outputs. Now when the combination is 0 0, then obviously I input will be routed through D0. So I will be routed through D0 and these are not used. When 0 1 combination, then I will be routed through D1, not by others. And when 1 0, it will be routed as input will be routed as D2, not by others. And when 1 1, then input I will be routed through D3 and not by others. So this is the truth table, and for all these combinations the enable should be equal to low. Means I can here also show that enable, this is for 0 0. Why? Because this is active at low, and when it is 1, then what's the combination of these two input lines? It hardly matters. The output will always be equal to 0. So this is the truth table. And the fourth point, we should know about the Boolean or logic expression that we need, and we derive this Boolean expression by making use of this truth table. So for D node, see S1 0, S node 0. So I is the input, S1 and S node complements, and obviously E is also complemented. And for D1, I S1 complement, S node and E complement. For D2C, I is the input, S1 S node complement and enabled. And for D3, I is the input, S1 S node and E complement. So this is the Boolean expressions for the 1 to 4 demultiplexer, and now we will, based upon this Boolean expressions, we will draw circuit. This is the logic circuit diagram of 1 to 4. We are having one input. That input is attached to all the AND gates, and enable is also attached, and S node and S1, which are the selection lines, they are attached with their respective combinations to its corresponding AND gate. And this all we did all the connections by looking at the Boolean expression. See, for D node, I will check you. I is the input. See, I is the input. Then S1 complement, S1 complement, S node complement, S node complement, and enable. This red line, this is enable. And you can check for D1 also. I, this is I, S1 complement, this is S1, S1 complement, S node direct, S node direct, and enable. This red signal is enable. This is actually at active low, because we are having one enable here to have its active low value. So these are the outputs based upon the Boolean expressions, and this is the circuit diagram based upon this Boolean expressions. So now if we want to check in the sense, say for example, consider that S1 and S node both are equal to 0. Now we will see that through which the output will be activated, means the input will be routed through which of these four outputs. So when S1 is equal to 0 and S node equal to 0, these are both the complements. So from D node we get I into 1 because enable is always active low. So this is I. For D1, I is there. One of the input S node is equal to 0. So no need to write further because For AND gate, if one of the input is 0, then the output will be 0. For D2, this one, so S1 is direct and S1 is equal to 0, so again this is also equal to 0. For D3, both the inputs of these selection lines are 0, so this is also equal to 0. So the input will be routed through this D node output, and this check actually validates our truth table. Means when S1 and S node both are equal to 0, then the input line will be routed through the D node output. So the input, what the input data is, that is routed through D node, means this output line, and for others it is 0. For others it is 0. And this, for all this, the enable is at active low, even for this also. So this is the way how 1 to 4 demultiplexer operates, and we will also name them as 1, 2, 3 and 4 AND gates. This is all about 1 to 4 demultiplexer, and in next lecture we will also come with some other types of demultiplexers. Thanks for watching.